Skylon's just a very powerful aeroplane. It's designed to take off from a fairly normal runway, quite long because it takes off quite fast, climb to orbit with 15-ton payload, leave it in orbit, re-enter, and then 2 days later you can do that again. That's quite difficult to achieve, and we've had to develop new propulsion technology in order to make that possible. The new type of propulsion technology essentially is to try to integrate a jet engine and a rocket engine into a single type of engine, so that once you've started it, it runs all the way from the ground into orbit. But the trick is that around about 26 kilometers and 5 times the speed of sound, it switches from being a jet engine to being a rocket engine. Now that in itself might not sound all that particularly demanding, but the problem is the air entering the engine when you're traveling at 5 times the speed of sound is around about 1,000 degrees centigrade, and a jet engine just could not handle that. Fortunately, we've got liquid hydrogen on board as the fuel. The liquid hydrogen's very cold, minus 250 degrees C, and liquid hydrogen's got an immense capacity to absorb heat. So we can actually cool the air that comes into the engine. In essence, what we've got is a refrigerator built into the sort of front of the engine that cools the air quite efficiently from 1,000 degrees centigrade down to about minus 140 by the time we get to there. That takes about 1/100th of a second to do that. So this heat exchanger that does that is a very, very demanding piece of technology. By actually doing that, we can achieve something like 5.5 times the speed of sound before we change the operating of the engine and it turns into a rocket. And from that point on, it's drawing liquid oxygen and its hydrogen fuel from on the vehicle. So Skylon's a general vehicle. It doesn't have a pilot, and it's got a 200 cubic meter payload bay. And you can put what you like in the payload bay, so you could put what we call a logistics module, and that would allow you to put 20, 25 astronauts in there. They could be tourists, but I don't think that that's going to happen with this generation of vehicle. Particularly what we'll be doing is opening up the accessibility of space to physicists, engineers, meteorologists and astrophysicists, so that they could get up into space, do a week's work on a space station and then come back for the weekend. Likewise, we should be able to get engineers up there to repair stuff that's already in space. In particular, what we want with Skylon is to have an aeroplane that we could sell to anybody in the world of an acceptable political stature, that they would then be able to have access to space for their own purposes, and by that route grow the utility of space. Space has got tremendous utility that can be exploited for the human race, and it's only going to be exploited if we can make getting there and using it as easy as going to Antarctica, for example. And so that's the objective of Skylon.